Welcome to Chapter 1, Cluster 2, Lecture number 2. So, we're taking a look at operations with fractions. Okay, so some vocabulary in case you need a reminder here. So the numerators, when I say the word numerators, numerators are the top of the fraction. Okay, so numerator would be on the top, and denominators are the bottom of the fraction. Alright, denominators are on the bottom. So, when adding or subtracting fractions, okay, they need to have a common denominator. What does that mean? Well, it means the number on the bottom of the fraction must be the same. For example, if I was looking at the fraction 1/5 and 2/5, these guys have a common denominator because both of the denominators are 5. Okay, so once you have a common denominator, we keep the denominator and then add up the numerators. Okay, so we add the top number. Oops, sorry, that's supposed to be a plus sign right there. Please go ahead and change that on your paper. That should be a plus sign. All right, so example 1, we're asked to add the denominator. Sorry, add the fractions, okay? Add, or what we might say is do as indicated. All right, so we're going to go ahead and add across. So the denominators are the same, so good, we can go ahead and add the fractions. We don't have to do anything. Okay, denominator is the same, so adding the fraction, so we'll keep it. It's going to be 6. And then 2 plus 1 is going to be 3. All right, but we need to simplify this. 6 and 3, they share a common factor. They're both divisible by the number 3. Okay, so if I'm going to simplify it like this, I need to divide the top and bottom by the same number. So 3 divided by 3 is 1. 6 divided by 3 is 2. Okay, so we have gone ahead and simplified into a half. All right, let's take a look at the next one. Can we add them? Yes, we can, because they have the same denominator. Okay, so we'll keep the denominator. Add across the top. 5 plus 4 is going to be 11. 11 and 7, we cannot divide them by the same number, so that is it. All right, so what happens if we do not have the same denominator? Okay, that's a good question. If we don't have the same denominator, we can't add them, but we want to add a fraction. So the plan is, if we do not have the same denominator, we're going to use the building up property. Okay, so what is the building up property? Well, you can multiply the denominator of a fraction by any number you want to, as long as you multiply the numerator by the same number. Well, that's great, but how does that help us? Well, take a look at this fraction right here, example 2. We want to add a third plus 3/4, but we can't add them because the denominators are not the same. So my goal is I want to make them have the same denominator. All right, I want the same denominator. To do that, we're going to use the LCD, lowest common denominator. Okay. So 3 and 4, let's see. I'm just going to go ahead and find multiples of 3. So 3, let's see, 3, 6, 9, 12, 15. We'll stop there for now. Multiples of 4. 4, 8, 12. Ah, look at that. Right there. They have a common multiple. 12. Okay, that's going to be our common denominator for 3 and 4. So I want to make this into a 12 plus a 12. The question is, how do I make a 3 look like a 12? Well, I'll multiply it by 4. But when I multiply the bottom, remember we're going to use the building up property. If we multiply the denominator by a number, we need to multiply the numerator by the same number. So I'll multiply the top by 4. So 4 times 1 is 4. 4 times 3 was the 12. Okay, we're going to do the same thing to the 4. What do we multiply 4 by to get 12? Well, we'll multiply it by 3. And then, with the building up property, I have to multiply the top by 3 as well. We cannot just multiply the bottom by 3. We have to multiply the top and bottom to balance things out. So 3 times 3 is 9, and 4 times 3 is 12. All right, now take a look. Now they have the same denominator. We're good, so now we can add them. So keep the denominator and add the numerators, and we get 13. 4 plus 9 is 13. Cannot simplify it, so there we go. That's our answer. All right, so this has to do with adding and subtracting. Okay. Oh, I just realized. Sorry. On this problem, that was supposed to be a subtraction symbol. So let's go ahead and just add a number problem right here. C. If we had 5 over 7 minus 4 over 7, what would that be? Well, 5 minus 4 is going to be 1. Since they have the same denominator, I can just go ahead and keep the denominator. So it works. This problem will work either way with a plus or minus, as long as you have the same denominators. Sorry about that. That was supposed to be a minus sign. We had extra practice. All right, so let's take a look at multiplying fractions. All right, to multiply fractions, this is a really big difference. Okay, please notice this. They do not need to have a common denominator. Okay, addition and subtraction, you do need a common denominator. But multiplying, you don't. So what is the plan? We'll simplify, multiply across the numerator, and then multiply across the denominator. So let's take a look at the first example. 4 over 5 times 2 over 3. Well, what is the plan? Multiply across the top. So 4 times 2 is going to be 8. And then multiply across the bottom. 5 times 3 is going to be 15. Can we simplify that? There's no number that can divide both of them, so that's it. We're done. Not too bad. All right, B. Okay, this one's a little more complicated because right now this is a mixed number. So our plan for mixed number is first change to an improper fraction. Okay, so first thing, let's change these. So it's going to be 2 times 6 is 12 plus 1, 13 over 6 times, that's going to be 4 times 2 is 8, 9 over 2. Okay, so that's the first thing we wanted to do was change it out of the mixed number into an improper fraction. And now we can go ahead and do what we were doing in the beginning. Multiply across the top. That's going to be 9 times 13. Let's pull out my sticky notes. 13 times 9, so 9 times 3 is 27. Then 9 times 1 is 9, plus 2, 11. 117. So across the top we get 117 divided by, multiply across the bottom, 6 times 2, which is going to be 12. And there we go. Okay, not simplifiable. All right, let's take a look at page 2. All right, so now we're looking at dividing fractions. So we've already seen adding and subtracting, and we've seen multiplication. Now we're looking at division. All right, so to divide fractions, you're going to keep the first fraction as it is, change the division sign to multiplication, and then flip the second fraction. So a way to remember it is just keep, change, flip. All right, so basically what we do is we don't like working with division, so we change it into a multiplication problem, which we already know how to solve. Okay, so notice is the division symbols. So let's go ahead and do this. But wait, 8's not a fraction. How can I work with 8 if it's not a fraction? Well, don't worry. Remember, if you ever have a whole number, you can make it into a fraction by putting it over 1. So now 8 is a fraction. Let me rewrite that. 8 over 1 divided by 1 over 2. Okay, so let's do our plan. Keep the first fraction. Change the symbol in the middle to multiplication. And flip the last fraction. So instead of 1 over 2, it's going to be 2 over 1. All right, so now, how do we continue to simplify? We'll multiply across the top, just like we've done with the other multiplication problems. That'll be 16, and then multiply across the bottom. That's going to be 1. The question is 16 divided by 1 simple? The answer is no. We need to simplify this. So to continue my work, I'm going to use this little arrow to show you guys where I'm going. So if you ever have to continue your work somewhere else, just use an arrow to indicate where your problem's going. 16 over 1 simplifies into just 16. Anything over 1 is itself. All right. Okay, ooh, look at B. We have another mixed fraction popping in. Okay, so the plan with the mixed fraction, we're going to change it into an improper fraction. So let's go ahead and do that. 2 times 2. Okay, so remember, you multiply, then add. 2 times 2 is 4, plus 1 is 5. All over 2, divided by 2 over 3. Okay, so now we have two fractions being divided. Let's go ahead and do the keep, change, flip. That's going to be keep the first fraction, change to multiplication, and then flip the second fraction. And there we go. So now it's just a regular old multiplication problem. Let's go ahead and multiply across the top. 5 times 3 is 15. All over. 2 times 2 is 4. All right, so if I wanted you to answer, so the moment this answer is an improper fraction, which most of the time I will accept, as long as it is simplified. Okay, so this is simplified. No number can go into 15 and 4. But if you wanted to answer as a mixed number, how do we do that? Okay, remember this is what a mixed number looks like there. This right now is an improper fraction. So to get a mixed number, what will we do? We're going to do the division. So we originally have 15 over 4. Well, to do the long division, 4 moves out and the 15 drops down. How many times can 4 go into 15? 3 times? Yeah, that's 12. What is the remainder? 3. So our answer is going to be 3, and you take your remainder and you put it under your numerator. So our answer is 3 3/4. Okay, so that is a way to get a mixed number. So if you're asked to answer as a mixed number, that is how you would do it. So mixed number, improper fraction. Both of them are acceptable since I did not tell you what form your answer should be in, as long as your answers are simplified. Always simplify your answer. Okay, so example 5, we're going to combine operations with our fractions. Okay, so take a look at these. We have, let's see here, we have parentheses and something going on in the parentheses. So remembering PEMDAS, we're going to go ahead and work on the inside. But oh, if you notice, these guys don't have the same denominator. Okay, so first we're going to go ahead and try and make them have the same denominator. So what's the common denominator for 6 and 5? Let's go ahead, find the LCD. Finding the lowest common denominator. Let's just do multiples. So 5, 10, 15, 20, 25, 30, 35. Let's stop there for now. Let's check multiples of 6. 6, 12. What's after that? It's 18. What's after that? 24. After that is 30, and then 36. Do they have any common numbers in their multiples? Aha! 30. 30 is going to be their lowest common denominator. So my goal is to create the denominator of 30. The question is, what do I multiply 6 by to get 30? We multiply it by 5. Very good. And then, because of building up property, we have to multiply the top as well. So 5 times 5 is going to be 30, 25. All right, so we've done the building up property for 5 over 6, and we got 25 over 30. Let's go ahead and do the building up property on 4 over 5. So how do we make 5 look like 30? Well, multiply it by 6. Then multiply the top by 6. So 4 times 6 is 24. All right, so remember, why do we do the building up property and why do we find the LCD? Because we want the same denominator. When we have the same denominator, then we can actually subtract these two fractions. All right, so let's see, let's subtract. 25 minus 24. That's going to be 1. 1 over, and then keep to the denominator, 30. All right, so now we have 2 times 1 over 30. Well, remember, we can make 2 into a fraction by putting it over 1. So we actually have a fraction times a fraction, which we know how to deal with. So multiply the numerators, 2 times 1, and multiply the denominators, 1 times 30. Can we simplify this? Let's see. Okay, so to continue my problem, I'm going to use my arrow, move it over. Please make sure to use the arrow if you are continuing a problem somewhere else. And there's my equal sign. 2 and 30, those are both divisible by 2. They're both even. So divide the top by 2, divide the bottom by the exact same number. It's similar to building up property, but it's like the reverse property. You can think of it that way. So 2 divided by 2 is 1, 30 divided by 2 is 15. And there we go, that's simple. Can't divide them by any other numbers. All right, so B, oohoo. Oh, well this one's not too bad. We have mixed number and a mixed number and subtraction. So with the mixed numbers and subtraction, remember, we're going to go ahead and change it to improper fraction. So that's 2 times 3, which is 6 plus 7. Sorry, plus 1 is 7. Minus 4 times 2 is 8, plus 3 is 11. All right, so in order to subtract 2 fractions, they need to have the same denominator. How do I make them look the same? Well, if I multiply 2 by 2, I could get 4, and then they'd have the same denominator. So let's go ahead and do that. Using the building up property to make the denominators look the same. That's going to be 14 over 4 minus 11 over 4. Let's see, 14 minus 11 is going to be 3. Keeping the denominator, 3 over 4. All right, let's see C. Ooh, this one is fancy. So we've got fractions over fractions. So it looks like a lot of stuff, but what I'm going to do is let's just focus on the numerator first. Can we simplify that? Well, those are just 2 fractions being multiplied together. I know how to deal with that. Just multiply across the top. That's 3 times 1. And then for the bottom, just multiply across the bottom, 5 times 2. We've dealt with this. Big division sign. And let's just do the same thing on the bottom. Those are just 2 fractions being multiplied together. I've done that. Oh, but look at that. That's going to be a 15 times a 24, which I do not know off the top of my head. So, pull out the sticky note. 24 times 15. All right, let's see. So 5 times 4 is 20. 5 times 2 is 10, plus the 2, 12. Okay, add the 0 to start the new cycle. If you need any resources on doing a multiplication like this, feel free to reach out and email me and I can send you some resources. 1 times 4 is going to be 4, 1 times 2 is 2. Add them up. 0, 6, 3. 360. All right, so we have 360 divided by, and then 8 times 5. That's 40. All right. Woo. Okay, so it looks a little less horrible. What do we have? We have a fraction divided by a fraction. Wait a second. I know how to write this so it looks more familiar to us. That's a fraction. I said divided by, see this division? Divided by another fraction. Do we know how to deal with this? Yeah, we do. We're going to do the keep, change, flip. Okay, so let's go ahead. Keep the 3 over 10. Change to multiplication. And flip the last fraction. That's 40 over 360. Okay, so let's go ahead. First, I want to simplify the 40 and the 360. Those are both divisible by 10. So dividing by 10, I can just cancel those zeros. And I'm left with 3 over 10 times 4 over 36. That looks a little better. Let me go ahead and just box off this section because I'm going to use it. All right, let's go ahead and continue this over here using my arrow to indicate where I'm going with my problem. So can I simplify these before I multiply them? Well, 3 and 10, they don't share a common number. But 4 and 6, those are both divisible by 4 actually. So 4 divided by 4, and then we can divide 36 by 4. What do we get? We get 3 over 10 times 1 over 9. Well, look, I just made the problem simpler by simplifying. Okay, so if you can ever simplify during your problem, it'd be a good idea because then you're working with smaller numbers. And most of us like to work with smaller numbers. If you like bigger numbers, it's very strange. All right, so let's go ahead and, see this multiplication? I can actually simplify the 3 and the 9 because the 3 is in the numerator and the 9 is in the denominator. I can divide the 3 by 3 and the 9 by 3, as long as you're dividing a top number and a bottom number. And remember, I'm allowed to do this because of the multiplication. So that's going to be 1 over 10 times 1 over 3. Okay, now everything is simplified, so I'll multiply across the top. It's going to be 1. Multiply across the bottom. 10 times 3 is 30. Can we simplify? Nope, that's it. There we go, we're done. All right, that was page 2. Let's go ahead and look at page 3. Ooh, applications with fractions. All right, so what's our plan? Underline the question. Okay, first things first, underline the question. Then we're going to write down the given information that relates to our question. Then we need to create an expression, solve the expression, and answer in a complete sentence. All right. That should actually probably be simplify the expression. Sorry. Okay, so let's see. As a member of a college choir, Lynn has 3 rehearsals to prepare for an upcoming performance. The sessions are 1 1/4 hours, 2 1/2 hours, and 3 2/3 hours long. What is the total time Lynn will be spending rehearsing for the performance? Okay, so the first thing we're going to do is underline our question. What is the total time Lynn will spend rehearsing? So we want to know how much time Lynn is spending. Okay? So what is the information that has to do with time? Well, we're not going to take the 3 rehearsals because that doesn't have to do with time. The items that do have to do with time are this number, and this number. Okay? So we want to know the total amount of time. So if she spends this much time on one, and then this much time, and this much time, we'll get the total. So that means we're going to add up all of the fractions to find out the total. All right, so we're going to add them up. 1 1/4 plus 2 1/2 plus 3 2/3. Okay, so here's my expression. I've created my expression. So now I'm going to solve, or actually it should be simplify the expression. Okay, to do that, first I'm going to do, because this is addition, I'm going to show you a slight shortcut you can take.